Hi, this is Dawit.
And I'm Martine, and we're going to be explaining our Hindmarsh nose neural model. Dawit's going to be holding the camera while I explain the circuit and what we're showing on the oscilloscope. Neural model that I did for EE122, where we were meant to take these equations and create an integrator circuit that would basically do the equations, or simulate the equations. Right here, you'll see my, come over here. Right here, you'll see my schematic that I followed to implement the equations. And the schematic is implemented on a breadboard with LT1058 and AD633. LT1058 is the operational amplifier and AD633 is the multiplier. Right here is my first X equation coming through an integrator and being inverted. The second one here, these are my Y, and this is my Y equation with my Y resistors and inputs. This is my Z with my Z resistors and the Z inputs. The Z also has a different capacitor. It's 1 microfarad as opposed to a 0.1 microfarad on the Y and the X. This is a capacitor that filters the noise because I use so many wires. My output for my X at a 1 volt is displayed right now. The 2 volt is now displayed. 3 volts displayed. And 4 volts displayed. I'll now change the op amp to the Y output. And then here's the Y output at 1 volt, output at 2 volts, output at 3 volts, and output at 4. I'm now changing it to the Z output.
And then we can easily switch.
This is the Z output at 1 volt.
Thank you.
The Z output at 2 volts, the Z output at 3 volts, and the Z output at 4 volts. If you'll see, the AD633 has the X input and it's shorted with itself so that it gets squared, and then you have the output from that to make the cubed. This is my 1 volt and my minus 1 volt for the Z and the Y inputs, and my 15 volts to power the operational amplifiers is over here. We're simulating the Hindmarsh Rose neural model, and this is my simulation. That was my LT Spice simulation, and this is my implementation on the breadboard.